Good morning, I hope everybody is doing well. Let's get to work. Right or wrong, doesn't matter. Effort is more important than anything. And of course, we want to leave here feeling confident that in the future we can have success. So, equity bars are in effect. Doesn't matter what you put, you just tell me what you put. Whatever question I call on you for. So let's start with number 1. What did you get? I got student 5, 19, and 21, and if the student's not here, I'll go to the next couple. So student number 5, what'd you put? Okay, student number 19. Student number 21. Okay, the correct answer is 12x plus 30. Number 2, simplify the expression. I've got students 9, 8, and 18. Student number 9. Student number 8. Student number 18. Not here. That's supposed to be 2 to the 7th power. I had a typo. So 2 to the 7th power. Sorry about that. If you put whatever the value was, I'm sure that's fine as well, but the whole point of working with powers is to be able to write larger numbers in a simple way. So it's not a matter of right and wrong, it's just a matter of what's the best way to write. All right, number 3, what's that? Simplified. I got student 2, 12, and 13. Student number 2.
Y to the 9.
Okay, student number 12.
Y to the 9.
Student number 13.
Y to the 9.
So I have 3 students in my room who know how to simplify that. Very good. And number 4, what do we get when we simplify that? I got student number 1, 20, and 11. Student number 1. Student number 1 is not here. Student number 20, not here. And student number 11. 5 to the 6th power. 5 to the 6th power. Number 5. I got student number 7, 14, and 16. Student number 7. Student number 14. Student number 16. So I got 3 people who think it's x to the 8th, and it is. And what about number 6? Number 6, I've got student number 12, student number 15, and student number 3. Student number 12. Student number 15.
-4x plus 28.
Student number 3.
Oh, -4x plus 28.
Negative 4x plus 28. Outstanding. We're going to get to number 1 in a moment, but let's start with 2 through 6. Now I have some follow-up questions. Number 6, can someone tell me in words what you had to do? In words. Natalie? You agree with that, Bunchakers? Distributed property, very good. What about numbers 4 and 5? What did you have to do there? In words. Andrew? Okay, why? What tells you to do that? Milan? That's part of it. Good. I guess I'm asking what property tells you to do it? You were absolutely right, Andrew. You multiply the exponents, but what property tells you to do it? Deja? I'm a little disappointed in your energy level saying that, but yes, that's correct. Is power of power. And I'm surprised more people didn't instantly know that since I talked so energetically about that particular scenario. And then what about number 2? What are you supposed to do? I'm sorry, number 2 and 3. What are you supposed to do with those two? What do you do, Emily? Add the exponents. Same base, multiplication, add the exponents. Very good. That's important. Now let's talk about number 1. Give me a thumbs up if you've got the correct answer. Okay, give me a thumbs up if you drew a picture that included the frame. Good, put your thumbs down. So if you didn't, I'm a little concerned because I don't often give hints during my warm-ups, and there was this big, giant hint here. And quite honestly, it's virtually impossible to have any chance if you didn't draw the picture. So now the question becomes, what does he mean, draw the picture with the frame? Well, we live in a world now where a lot of photographs are dealt with digitally. We look at them on a tablet or on a phone or on a computer. We don't actually have picture frames nearly as much as we used to. But I am willing to bet that you've seen a picture frame at some point in your life, or have one in your home somewhere. And if you don't, look up at my posters that I have across the top of my room. Let's look at this one all the way on the end. Junk Food In, Junk Brain, Healthy Food In, Healthy Brain by Tony Buzan. What's the frame of that? How would you describe the frame? Only 2 students could describe the frame. Go ahead, Mark. What's the frame?
The frame is the
Yeah, the pinkish purplish outline of the poster. That's the frame. So this, in this picture, this is the photograph. There's no frame indicated here. So what I wanted you to do was draw a frame. So to do that, you needed to draw an additional rectangle outside of it, like so. That's part of the idea. But let's back up for a second. Let's start with this. If I asked you for the perimeter of this, how would you find the perimeter of just the photograph? This is one of those situations where everyone's hands should be frantically waving in the air as opposed to the tumbleweeds that are drifting through my room. Angela? Add up all the sides. Well, I don't see this side down here, so what's this side down here? Are you sure? Yeah, it's 4x plus 8, of course. Excuse me. This is 4x plus 8 because this is a rectangle. What about the left side? I don't see the left side there. Natalie? 2x plus 3 because it's a rectangle and the opposite sides are going to be congruent. So, of course, if you want to find the perimeter, you have to add up all the sides. Now, we could write that out, or we could just say, oh, well, I'm an expert at combining like terms, and I could add that, and that, and that's 4x, 2x is 6x, 10x, 12x. And then I can add the numbers, because I've been adding numbers since I was about 6 years old, and I could add 8 and 3 and 8 and 3 and get 22. So the perimeter of this would be 12x plus 22. Give me a thumbs up if that makes sense to you. Good. But unfortunately, that's not what I asked you for. What I asked you for was the perimeter of this. I asked you for the perimeter of the outside of the frame. So let's start with just the top. So what I want to do now is I want to focus, and then I'm not going to tell you anything else. I just want to focus on, we have to know that distance going across, right? So I want to focus on that. So I'm going to draw a line over here. I'm going to draw this. What's the length of that line? was a simple question. What's the length of that line? I'm sorry, we seem to be having trouble. Look at what I drew. What's the length of that line? Deja? Where are you getting 12 from? I'm sorry if I'm doing this too quickly. I just copied this line right here. And I'm asking you, what's the length of that line? I'm literally asking you to read something to me. I'm not asking you to do any thought. The thought there's a lot of thought involved. But right now I'm asking you to read something to me. What's the length of that line? Shannon? That's 4x plus 8. So I'm sorry if I'm not being clear enough, but I'm asking you a simple question. That's 4x plus 8. But we don't need to know this distance to find the perimeter outside. We need to know this distance from here to here. Right? So now, let me take this. Watch this. So what is the distance between the green dots? Because this is 4x from here to here. That's 4x plus 8. But we need the distance from the green dot to the green dot. So let's talk about that. So what we're doing is we're adding on a small line over here, and we're adding on a small line over here. And now I want to know the distance from here to here. What is the distance? I need to know the distance from there to there. What is the distance? Well, let's back up. How long is that little blue line that I just put in? Gloria? It's 1. Where'd you get that from? Yeah, from the question. This was a 1. How long is the little blue line on the left? Diane? It's 1. Now someone tell me, how far is it all the way across? Got 5 people who know? What do you think, Vontravius? 6? Where are you getting this? Where are you getting 6 from? So you add 2 to 4x plus 8 and you get 6? Oh, well now it's making a little more sense. You add 1 and you add another 1. You don't add it to that, right? That's not a like term. So this, of course, is 4x plus 10. Of course that's 4x plus 10. See, one of the issues that we're having is you don't understand what I mean when I say distance. Distance is a straight line. From here to there. From here to there. It's a straight line. So when you talk about perimeter, it's a sum of distances around a shape. I understand it's a shape, but it's still a distance, a distance, a distance, and a distance. They're straight lines. So you have to understand and be creative about how you view this. That this distance is really from here to here, plus here and here. You have to put it all together. So now we know the distance across the top of the frame. What's the distance across the bottom of the frame? Here's another situation where my hand should be waving frantically in the air. Oh, I know, Mr. Gallett, I know. It's so easy, right, Daniela? What is it? Right, because of course it's a rectangle, so the top and the bottom are going to be the same. What about the right? What's the right-hand side going to be? The distance from here to here. Oh, so now it's clicking for some of us. Gloria? Yeah, that's going to be 2x plus 5. And what's the left side going to be, Gloria? And so now we add those 4 distances together and we get the actual distance around the whole thing. So that was not easy in any way. Nor am I even implying that it should have been easy for you. Absolutely not. However, we need the foundation ideas to work through it. You need to understand what distance means. You have to understand what you're allowed to add and what you're not allowed to add. Okay? Anyone have any comments or questions on this? So we just spent about 10 minutes on one question. Do you think maybe it's an indication of its importance? I'm going to give you a heads up that you're going to see it again. And I will expect a higher level of success now that you have a little experience. Is it going to be the same question? Of course not. Are you going to have to be creative and thoughtful? Absolutely. Any questions? Any questions on today's warm-up at all? Okay, of course, across the top of your paper, you titled your lesson 6-5 Part 1. Make sure you title it Part 1. There will be a Part 2. But today and the next lesson is a case where I'm going to wrap them all together as one lesson. So at the end of today's lesson, you're going to get a homework assignment. You will only know how to do part of it. You should do the part that you know. Next time I see you tomorrow, you'll learn the other part, and then we'll wrap it all together. Any questions about that? Good. So, our objectives today is to learn how to multiply polynomials. So here are your notes. Go ahead and start copying, and then we'll discuss.
No, there's no notes.
Amazing.
So here's some notes. So go ahead and get started, and we'll discuss. So of course, I'm being super silly on purpose. I could have just skipped over this slide, right? There's nothing there, right? There's no purpose to it. But there is a purpose. What's the purpose? What's the purpose, Tatiana?
To tell us that we already know our notes,
Yeah, you said that nicely. The purpose is to remind you that you actually already know everything. The only thing that's different is context. Scenarios, situations, maybe level of complexity. Multiplying polynomials. Let's go back to today's warm-up. Just looking at 2, 3, 4, 5, and 6. Give me a thumbs up if you've got all of those correct. Good, put your thumbs down. Congratulations, you now know how to multiply polynomials. Because that's exactly what you just did. This is multiplying polynomials. That's a monomial, that's a binomial, you multiply. So today is just multiplying polynomials extreme. Okay? So, let's jump in. Multiplying monomials. Don't go ahead. Before we jump in and start, there's two different analogies that I want to remind you about that we've talked about before. And so I'm going to write some things in green. Don't write them down. But you, of course, pay extra close attention. So we've talked about this quite a few times. And the fact that 3 times 2 times 5 can be rewritten as 2 times 5 times 3, and you'll get the same result. In fact, if I added in another number, it wouldn't change the fact that we could switch around anything that I wanted. For example, I could take the 5 and put it over here if I felt like that would help me. Or I could take the 2 and move it over here if I felt like that would help me. In other words, I could do 5 times 10, then do 3 times 2, and then multiply the results together if I wanted to. Or I could just put it in this form and do 10 times 2 times 5 times 3. I could do this a whole bunch of different ways, but no matter what, because it's all multiplication, I have flexibility. I can rearrange the factors any way that I would like. Does anyone have any questions or concerns about that? So this is something you digested and mastered a long time ago. So now, we're going to apply that same principle here. But before we go ahead, I want to remind you of the second thing. We've talked about sports a couple of times. What were the two sports that I jokingly talked about? Diane?
Cricket and baseball.
Cricket and baseball. I also threw in basketball, right? And I was impressed. You guys seemed pretty familiar with cricket. So, but the point is that there are different rules. And you have to be able to tell the difference on what rules apply at which situation. Am I playing baseball right now or am I playing cricket right now? That's the kind of a thing that's going on, okay? I'm going to expand on this idea in a little while. Anyone have any questions? Good, so now let's go ahead and get started. So, you already copied down part A? How'd you copy it down? Look at what you wrote. Did you write it the way you should have written it? So, I see a lot of heads shaking, and that's fine. We're here to learn, and we're here to gain confidence. But what you should have written was this. This is one big multiplication. How do I know? Because I know. I can see it. So we should have written this. And so this is no different, in essence, this is no different than what I was just writing in green over on the side. Because watch what we can now do. The 6 and the 3 go together. So we can rearrange this like this. And the y to the third and the y to the fifth go together. So I can move that over there. And then I still have this multiplication in between, so then the results will get multiplied together. So let me ask it this way. Daniela, if I asked you to just do, if I asked you to just do that, could you do it? Okay. Daniela, if I just asked you to do that, could you do it? Okay. Here's how I know that all of you could. Because I just asked you a moment ago how you did on this, right here. And most of you told me that you had great success with that, right? Same base, multiplying, what do we do with the exponents? Isabella? Add them. So, nothing has changed. So we now have 3 times 6, I don't need any volunteers for that, 18. What about y to the third times y to the fifth? What will we get as a result for that? Isabella, you're on a roll. Keep it going. Y to the 8th power. We have now multiplied monomials. Did we need new notes and new definitions for that? Did we need new ideas? It was just a matter of context. It was a matter of seeing it in a new way. Does anyone have any questions or comments about Part A? Now, of course, this is Algebra 1 Honors, so we need to now elevate the levels that we are working. And so let's go next level. Wait, pause. Are you writing it the way you're supposed to be writing it? Oh, now I'm getting some affirmative nods. This is good. So now, some of you are already off and rolling, but before you actually continue, now I have a slightly different question. And be very honest. Give me a thumbs up if your brain already started moving things around without you even doing it. Okay, Angela, what kind of moved for you in your mind?
The M moves together, the N and
Okay, so if you're not there yet, that's fine. Every class I've asked, I've had a few people right at this point. But by the end of the day, Most of my students are telling me, oh wow, it's just kind of happening all of a sudden. And so, yeah, that's what we want. We want you categorizing things using the creativity of your mind. And so what should be happening is the 9 should kind of, in your mind, automatically jump over there. And in your mind, the m squared should kind of jump over here, and the n squared should try to jump over here. And now things have kind of been categorized. But you have to follow rules now. You have to say to yourself, okay, this is all multiplication, so multiply, and then multiply, and then multiply, and then put it all together. So let's do it. We've got 9 times 3, of course, that's 27. What about m times m to the second? What do we get when we multiply those two? Emily? M to the third. What about n squared times n? Milan? N to the third. And the best practice, the standard convention for writing an answer, when you write your answer, you don't write multiplication dots. When you're working, you do use multiplication dots. And so this is the best way to write the answer. 27, m to the third, n to the third. Anyone have any questions about that? Any concerns of any kind? Any observations? Okay, so let's continue to up the complexity. Now I'm going to pause you again. How did you write it? How'd you write it, Sean?
1/4 times s to the second times t to the second times s times t times negative 12 times s times t to the second.
Now every time you said times, was that saying that there was a multiplication dot on your paper? Anyone write it differently? What'd you write, Tatiana?
1/4 times negative 12 times s to the second power times s times t to the second power times t times t to the second power.
See what she did? Is she allowed to do that? Yeah, of course. What a brilliant approach. The numbers are now going to come together. She now knows it because she's now achieved enough confidence and enough experience to say, oh, well, I'm going to eventually have to do this, so how about I just write it like that? And I'm going to eventually have to do this, so how about I just write it like that? And I'm going to eventually have to do this, so how about we just write it? Some of us don't even need to write it like that. Some of us are already at the point where we just kind of see it and do it. Wherever you're at, it doesn't matter. It's a matter of we want success. So, now we've categorized each set of factors. Those go together, and those go together. So, I know the dreaded fractions are here. What do we get? 1/4 times negative 12. Angela? Very good. Negative 3. What about s squared times s? What do we get? Natalie? S to the fourth. Nicely done. And what about t squared times t squared? Shannon? T to the fifth. Very nicely done. Anyone have any questions or concerns? Any concerns about any of it? So, is this exactly the same as the warm-up right here? No. But is it the same ideas just raised to a more complex level? Absolutely. Any questions? Any observations? Good luck. 3 questions. You got 3 minutes. If there's still time on the clock when you are done, compare your answers with your teammates. If your teammates have disappeared, then you're more than welcome to compare your answers with teams in front of you or behind you.
It's a bridge.
All right, hopefully you had a chance to feel successful and also compare your answers with your classmates. I'm going to call on students using the equity bars. If the student is not here, I will just go to the next student, so it'll take me a minute to figure it out. All right, for part A, I got student number 9, 17, and 12. Student number 9, what do you say? Okay, student number 17. Right here, student number 12. So I believe you agree, 18x to the 5th. What about part B? I got student 14, student 10, and student, no, not there. Student 14, 11, and 6. Student number 14.
10 r to r squared and r.
Okay, student number 11.
T. Oh.
Okay, student number 6.
T to the fourth, r to the 6th.
Okay, so it seems like we got some disagreement. So it's 10r squared t to the 4th. If you put t to the 4th first, that's fine. But usually when we write these things, these expressions, we write the letters in alphabetical order. So r comes before t alphabetically, so usually, but it's not that big a deal. And what about the beast-looking question? We got student 21, student 7, and student 2. Student 21.
4 times x to the 5th times y to the 5th times e to the 7th.
Okay, student number 7.
4 times x to the 5th times y to the 7th.
Okay, student number 2.
4 times e to the 7th times x to the 5th times y.
So it's basically the same thing, just in a different order. And I've already talked to you a number of times about how when it's all multiplication, you can switch around the order. One thing you want to make sure of, number always comes first. That's called the coefficient. Anyone have any concerns about anything we've done here? Now, at this point, I could care less if you got them all wrong. I could care less if you got one wrong, and I really don't care if you got them all right. But knowing how you did helps me know what to do next. So give me a thumbs up if you got all of them right. Good. Put your thumbs down. Does anyone have any questions at this point? So now, let's bring it to the next logical level. Give me a thumbs up if this looks familiar to you in some way. Sean, what does it look? How does it look familiar?
Example before.
Which one?
All of them.
Oh, it looks just like the ones we did? Okay. Okay. I lost my thumbs up. I don't know. I don't remember who it was. I keyed in on him. Who else? Mark, what do you see as familiar?
Well, I just see like this. Just
Seems like what?
distributive property.
Distributive property. Oh. Okay, so you thought it looked just like the ones before it, and you think it looks like distributive property. So because let's look, did we use distributive property for any of these? No, because they were just all straight multiplications. So what is different in this one compared to these? I'm glad Sean said what he said. What's the difference between these and this? What's the major difference? Emily?
There's a number outside the parentheses.
Okay. But in essence, there's a number outside the parentheses here. Like here's parentheses and there's a number outside of that parentheses. So you're right, it looks a little bit different. So let's do this. What if I put parentheses here? Like that. So now is it the same as the one we just did? Or is there something different? Natalie?
Everything has to be multiplied by 4.
Everything has to be multiplied by 4. Is that what we did over here? Did everything get multiplied by 3 or just? Yeah. So there is something different. We're still kind of missing the simple little difference. You don't see what the simple little difference is? Got a couple people starting to get some light bulbs. Shannon?
There's addition and subtraction.
Yeah, there's addition, subtraction now. There's addition, subtraction, and multiplication. So now I want to talk to you about a new sport. It's not new. Probably new for you, though. Anyone played gator ball? Give me a thumbs up if you've ever played gator ball. Never played gator ball? Okay. So this was a sport when I was in high school that I think the phys ed teachers either made up or someone had kind of made up and they took. Very cool sport, a lot of fun. So if you're looking for something different to do with your friends, very cool. So here's how the sport works. You play with a soccer ball. So we're going to pretend that this is a soccer ball. It's not, clearly, but we're going to pretend. You play the game with a soccer ball, and there's a net on either end of the field, kind of like in soccer, but the net's a bit smaller. And it's a big field. And you split into teams of like 10 on each side. And here's how it works. If the ball is on the grass, on the field, if it's already on the grass, you have to use soccer rules. So you can literally kick the ball around, you can kick it to a teammate, the teammate could kick it into the goal and you score a point. But if at some point a person kicks the ball up into the air, you're allowed to catch it. As soon as you catch it, you now have two choices. You can either change it to basketball or football. If you want to change it to basketball, this is real, I didn't make this up. If you want to change it to basketball, you have to keep a pivot foot, so you can't move. You can move around like this, and you can hold the ball. But then the other team can't touch you. All they can do is put their hands up and try to block you, and then you can throw the ball to a teammate. Okay? And then the ball stays in the air. Or, if you want, you can hold the ball and run like in football and try to throw the ball into the goal. But if you're running and holding the ball and someone tags you, like two-hand touch football, then they get the ball. Then, if you're running and you try to throw the ball to a teammate and they accidentally drop it on the ground, what do you think happens when the ball hits the ground?
Soccer.
Now it's soccer again. And now you can't touch the ball until someone kicks it back up into the air. And so it ends up being a very cool sport in the sense that a lot of creativity, and it's very complex. And it's if the first time you're playing it, everyone's like lost. Like they don't know when, oh, wait, can I touch it with my hands now? Or wait, can I run and pick it up? No, can't do that. So you have to pay attention to what's going on at that exact moment, and then the rules change while you're playing the game. So what's the point of my story? What's the point of the story, Gloria? Right, but not only do rules change, do you still have to know the rules for each individual sport? Okay, but then in a second, it could change from one sport to another, and then it might change back, right? So the point is this, is that the same thing is happening here, is that there are rules for multiplying a number or a monomial times a monomial. So if I asked you just to do this, if I asked you just to multiply that times that, there's rules for that, right? But now, as Shannon pointed out, now there's addition and subtraction. There's rules for that as well. Like if I asked you to do this. See, now watch. Now all of a sudden we're going to get confused, right? What's 2x plus 3x? Oh, wow. See? I would have thought that hands would be flying, right? But now we're hesitant because we're like, wait a minute. Is it basketball, football, or soccer? So what is it? 2x plus 3x, Von Travius? It's 5x. Because now we're combining like terms, right? Combining like terms is like one of the sports. Multiplying is like one of the other sports, and you have to be able to tell the difference. And so that's where we're at now. And so you've got to be very careful. But it goes back to what Mark said. This is distributive property. We already know how to do it. It's this times this, that times that, that times that. But now we just have to pay attention to the rules. So it's 4 times 3x squared. So now you can join me. We're working together. 4 times 3x squared is the first arrow. But now we have this plus sign here. Then it's 4 times 4x. Then we have this subtraction, but we know that that's really just addition of a negative number. So you can see that that's a negative 8. So really there's another plus sign. And this is 4 times negative 8. Like that. So we did distributive, so we followed one rule. But now we have to follow the rules for that, follow the rules for that, and follow the rules for that. So what do we get when we do 4 times 3x squared? What do we get as a result of that? See, confidence kind of went out the door. Now we're not sure. Milan?
12x to the second.
12x squared, of course. 4 times 3, x squared. What about 4 times 4x? What do we get as a result of that? Deja? 16x. And what about 4 times negative 8? Sean?
Negative 32.
And of course, when we write that, we don't put plus negative 32, we just put minus 32. And then we go, okay, 12, 16 that's 18, 28 minus 32 is negative 4. X squared and x is x to the third, so we get negative 4x to the third, and we circle it, and we're super happy.
Yeah.
Anyone have a comment on that? No? Just going to let me do that?
I know you can't do that anyway.
Oh, so no one wants to say anything? Yeah, you can't do that.
You can't do that.
Because that's like the ball is on the ground and I just reached down to pick it up and I was supposed to be following soccer rules. No, you can't do that because it's just what Von Travia said a few minutes ago. Now it's combining like terms and none of these are like terms. I can't do that. This is it. That's where I stop. Does anyone have any comments or questions? Good, we're doing well, so let's now accelerate, work at a higher level. So I will say that I have some students who, when I go from part A to part B, they get very lost. So I'm going to just give you a heads up that I'm not going to slow down, but it might get a little confusing for you. So you got to pay attention to what's happening. So this is distributive property again, here and here. So it's going to be this expression, 6pq. But if I write it the way I was taught, I'll write it like this, and this is going to help me a lot. Because now it's times 2 times p. That's just the first arrow. Plus, and now I've got 6 times p times q times negative q. Well, kind of like I did earlier, I asked some students, well, if I just asked you to do that, could you do it? And if I just asked you to do that, could you do it? So now I'm just asking you to do it twice. And this is the point where I had checked to see if anyone's brains were kind of doing the categorization for you. So look, 6 and 2. 12, excuse me. That's 12. P times P. P squared. Q. There's a Q. Plus. That's that different rule. Now, categorize. Oh, 6 times negative 1. Oh, that's a negative 6. P q to the second power. And now just rewrite it so that it's in the proper form. 12p squared q minus 6pq squared. I am not trying to imply that that's easy in any way, but it's the same thing, just more complex looking. Again, if I just asked you to do this, just that, you shouldn't have a problem because I asked how many students got all 3 of these right, and almost everyone put their thumbs up. And so all I'm asking you to do is do this 2 times. That's why there's, excuse me, that's why there's 2 of them. Anyone have any questions about that? Any concerns? Good, let's see how you do on your own. Checkpoint number 2. You got 3 of them, you got 3 minutes. 1 minute per question. If you have time left over when you're done, compare your answers with your teammates. people still finishing up, take one more minute. That's fine. One more minute on the clock. All right, now your time is up. Let's see how we did. Part A, I got students 7 and 21. Student number 7.
8 times x to the second power plus 2x.
Okay, student number 21.
8 times x to the second power plus 2x.
So I think that was the same thing, and that is correct. Very good. Part B, I've got student number 14 and student number 5. Student number 14, what do you say?
15 times a cubed times b plus 3 times a times b squared.
Okay, student number 5, what do you say?
15 times a to the third times b plus 3 times a times b to the second.
I'm pretty sure that was the same thing, and that is correct. And part C, I got student number 8 and student number 12, student number 8. Hurry up. I'm going to come back to you in a moment. Student number 12.
Negative 15 times
Okay, and where's student number 15?
5 times r to the third times s to the second minus 15. Minus 15 times s to the third times r to the second.
Okay, so we have some disagreement. And so we get 5r to the third s squared minus 15r squared s to the third. If you had those in a different order, if you put the negative 15r squared s to the third first, that's okay. So you could take this whole thing and move it over here, and take this and move it over there, that's fine. Yes? Yeah, you put them in alphabetical order. Any other comments, questions? Okay, so there were 3 questions. Give me a thumbs up if you got 2 or more correct. 2 or more correct. Good, put your thumbs down. Does anyone have any questions on any of them? Emily, do you know where you went wrong on part C?
Yeah.
Okay, good. Deja? Okay, so now you're getting, and it's very natural, now you're getting confused between soccer and football. You're trying to take a rule that doesn't apply and transfer it over to a different sport, okay? You can combine like terms if these were the exact same thing. If this was a to the third b plus a to the third b, and this was a 10a to the third b, and this was a 2. Those are like terms because this is addition and they have the same bases with the same exponents. Then you can add the coefficients and you get 12a to the third b. But if they do not have the exact same bases and exponents, you cannot add them together. Okay? And so that's why you can't add these. Very natural what you thought. Very natural. So don't stress about it. Just try to work through it.
If the addition sign was a multiplication sign, we'll be able to add them, right?
If it's a multiplication sign, then it's different rules. Then it's just one big multiplication, and then you would do something different. Absolutely. Okay? Very good questions. All right. We did have a real-world application, but this is part 1. We will wrap it into part 2, so I'm not really concerned about it. And here's your homework assignment that will apply to parts 1 and part 2. And so there's some of it you'll be able to do, and some of it you won't. And you will have a test on chapter 6 next week. And remember to do your typing practice.